Hello guys, welcome to my YouTube channel. Today we shall be discussing about organic chemistry, and I promise to take it in a language that even a layman will understand. Please, if you are new here, kindly subscribe to this YouTube channel. Organic chemistry, as defined in the olden days, is the chemistry of plant and animal. Not until in the year 1828, when one man called Frederick Wohler was able to synthesize organic compounds in the laboratory. Frederick Wohler in the year 1828 was able to synthesize urea by slowly evaporating water solution of ammonium cyanate, which he had prepared by adding silver cyanate to ammonium chloride. This is the nature of the reaction. This sign here shows that heat was applied for the product to be formed, and the product here is urea. Therefore, urea is the first organic compound synthesized in the laboratory. Then, after the invent of 1828 by Frederick Wohler, organic chemistry was now redefined as the chemistry of carbon and its compound, in the extension of some of the compounds such as the triisocarbonates, the carbides, the carbon 4 oxide, and the carbon 2 oxide. So any other compound containing carbon outside all these ones in exception are considered as organic compound. Let's look at uniqueness of carbon. Since everything is revolving around carbon, let's now look at those things that differentiate carbon from other elements. There are several uniqueness of carbon. Number one, carbon can easily combine with other elements such as nitrogen, oxygen, hydrogen, and the halogens. Again, carbon can form either single, double, or triple bond, and the number of bonds in the compound is referred to as the bond order. We'll look at some examples of single, double, and triple bond. This is carbon forming single bond, and this is carbon forming double bond, and in the last one, carbon was able to form triple bond. This single bond shows that this family is saturated, and this is coming from the family of alkane, whereas the double bond shows that the compound is unsaturated. If you look at this place on the other side, there are no hydrogens attached there. Lest I forget, with all these signs here, even if I don't write the hydrogen, just bear in mind that there are hydrogens attached all over. This one now is in deficiency of 2 hydrogen, which makes it unsaturated with double bond, and it's coming from the family of alkene. The last one is unsaturated with triple bond. If you look at this now, you will see that one hydrogen is lacking here, one is lacking here, another hydrogen is lacking here, and another one there. This family is unsaturated with triple bond, and it's coming from the family of alkyne. Don't bother yourself, just hit the subscription button if you are yet to subscribe, and I shall walk you through all these families I mentioned now. With this 3 carbon here, you can call this propane, and if you look at the rest of the 2, they all have 3 carbon each. Therefore, the name prop will be maintained in all of them. The only thing that will change is the ending of the names, which will be derived from the family. The first one is propane because it's coming from the family of alkane. The second one is propane because it is coming from the family of alkene, whereas the last one is propine, telling you that the family is alkyne family. The third uniqueness of carbon we shall be looking at is the tetravalent nature of carbon. Carbon has 6 protons, which makes the atomic number 6, and it has a mass number of 12. Therefore, carbon belongs to group 4, period 2 of the periodic table, and it has this configuration: 1s2, 2s2, and 2p2. That is to say that carbon in its ground state has 2 unpaired electrons. This is the ground state of carbon. Now, when carbon is excited, 1 electron from the 2s orbital will be decoupled to complete this empty orbital in the 2p set. And when that happens, carbon will be left with 4 unpaired electrons, which gives it the tetravalent nature. This is a configuration of carbon in its excited state, which gives it its tetravalent nature. The last uniqueness of carbon we'll look at is catenation. Catenation is an exceptional property of carbon. It's exceptional property because it is only carbon that exhibits this particular feature, and it refers to the ability of carbon to combine with itself to form a straight or a branch structure. For example, we have these two compounds. This is an example of a straight structure, whereas this shows a branch structure. If you look at this now, you will see that the carbons are aligned. In the second one, carbon is attached in the middle of the straight chain. If you want to name these two compounds using the International Union of Pure and Applied Chemistry standard, the rule says count the longest continuous carbon chain and use that as a parent name for the compound. And when counting, you count from the side that gives the shortest distance to any branch at all. Like here, you're going to count from the side that gives the shortest distance to this branch. But here now, in the first one, there is no branch. So the longest continuous carbon chain is 1, 2, 3, 4. 4 carbon. And the 4 carbon is butane. Butane, in the sense that this carbon is saturated because it has a single bond all through. Don't worry about how the names are being gotten, because those are the reasons why I'm taking this class gradually, so that every one of us, we understand where each name is coming from. So the only thing I owe you is to walk you through everything you're supposed to know in organic chemistry. Just make sure you don't forward this video. In the second one, we're going to count from the two sides. So you count 1, 2, 3. On the second position, you have a branch. Even when you count from the other end, 1, 2, 3, it's also located in the second position. You count from any side you like, since the two sides gives you equal distance to the branch. And here, the longest continuous carbon is propane. And in the second position, you have CH3. You have C and 3H. So you call that methyl. The name is going to be 2-methyl propane. The 2 attached there is telling you the position where the methyl is attached in the continuous carbon chain. These two compounds will have the same molecular formula as C4H10. That is to say that this second one is just an isomer of the first one. Throughout our study of organic chemistry, there are 3 basic things we shall always mention. They are hybridization, functional group, and homologous series. Let us look at these 3 things individually so that we will know more about them to avoid being confused whenever they are mentioned in this video. Hybridization is the combination or overlap, or you can also say is the joining of 2 or more atomic orbitals to form a molecular orbital. Basically, it is classified into 3, where we have the sp3, the sp2, and the sp hybridization. The sp3, otherwise called the tetrahedral hybridization, the sp2, also called trigonal, and the sp hybridization, which is also the diagonal. Let's discuss the types of hybridization individually. We'll start with the first one, which is the tetrahedral hybridization. Recall the configuration of carbon in its excited state when we talked about the tetravalent nature of carbon. This is exactly how it looked like. The sp3 hybridization is a combination of the 2s, 2px, 2py, and the 2pz atomic orbital to form a molecular orbital. just like we defined in the hybridization, that is the combination or the overlap of two or more atomic orbitals to form a molecular orbital. So in the case of tetrahedra, it needs these 4 atomic orbitals to form a molecular orbital. And the bond angle, when we talk about sp3, is 109.5 degrees. It occurs in the saturated hydrocarbon alkane. The second one is trigonal hybridization. It's the combination of the 2s, the 2px, and the 2py. So you need 3 atomic orbitals to form the trigonal hybridization. It has the bond angle of 120 degrees. This particular type of hybridization occurs in the unsaturated hydrocarbon with double bond, and that is alkene family. The last but not the least, when you talk about hybridization, is the diagonal or the sp hybridization. This occurs in the unsaturated hydrocarbon with triple bond, and that is alkyne. Let's quickly look at characteristics of organic compound. What are those things that when you see them in a compound, you will identify them as organic or inorganic? Number 1, we have that carbon atoms form stable covalent bonds with one another. When you talk about organic compound, it's always in between 2 nonmetals, and the bond between any compound involving 2 nonmetals is covalent bond. Number 2, carbon-hydrogen bonds are nonpolar, like the carbon-carbon bonds. This is because of the almost equal electronegativity of the 2 elements. Most organic compounds are nonpolar unless the compound consists of very electronegative elements like the chlorine or the group like hydroxyl group. And number 3, they have low melting and boiling point compared to inorganic compounds. That is self-explanatory. Organic compounds are thermally unstable and can decompose into smaller molecules when heated above 500 degrees Celsius. And number 5, reactions involving organic compounds tends to be much slower than the ionic reactions in the inorganic compound. It's self-explanatory. Number 6 is talking about the combustion. Organic compounds, especially the hydrocarbons, bonds in the presence of oxygen to produce carbon dioxide and water. And whenever you're balancing a combustion reaction, there's a special formula for it. The formula is a CXHY plus X plus Y over 4 into brackets O2 to give you XCO2 plus Y over 2 H2O. Assuming methane combusts, that is methane bonds in the presence of oxygen to give you water and the carbon dioxide. How do you balance this chemical reaction? From the formula, the value of X here is 1 and the value of Y is 4. So you are going to substitute the value of X and Y in this equation and see what it gives you. And that will be CH4 plus 1 plus 4 over 4 O2 to give you CO2 plus 4 over 2 H2O. 4 over 4 is 1 plus 1 is 2. So that is plus 2O2 to give you CO2 plus 4 over 2 is 2. That will be 2H2O. And finally we have CH4 plus 2O2 to give you CO2 plus 2H2O. How do you check if it is balanced? At the right hand side you have 1 carbon, and at the product side you have 1 carbon also. At the right hand side also you have 4 hydrogen, and at the product side you have 2 times 2, which is 4 hydrogen. At the right hand side also you have 2 times 2, which is 4 oxygen, and at the product side you have 2 oxygen here and 2 oxygen in the water molecule. So that is how you balance combustion reaction, in case you are giving one to balance. And for those of you in West African countries that sit for WAEC, this is WAEC syllable, and you don't have to play with it because you see it in your exams. Let us talk about the next important terminology when we talk about organic chemistry, and that is functional group. Functional group is an atom or group of atoms that is radical or bond common to particular homologous series, which is responsible for the chemical properties of that series. Wherever these functional groups are found in a compound, they are the ones that will determine the chemical property of that series which they are found. What are the functional groups? Let's look at some examples of them. We have the OH called the alkanol. We have the COOH, which is the alkanoic, or you call it carboxylic. We have the CHO, that is the alkanone, the NH2, which is amine, and we have CONH2, that is amide. As we proceed, we shall be looking at more examples of functional group and how each of them behaves. In the definition of functional group, we said it's an atom or group of atoms common to a particular homologous series, which is responsible for the chemical property of that series. A brilliant student would quickly ask, what is homologous series? Now let's look at what homologous series is all about. It is a family of organic compounds which follows a regular structural pattern in which each member differs from the successive one by CH2 or 14 grams per mole. This is what I mean. Carbon has atomic mass of 12. Hydrogen has atomic mass of 1, but there are 2 hydrogen there. So 2 multiplied by 1 is 2. And 12 plus 2 is equal to 14. That is why at times it will be seen as CH2 or 14 grams per mole. Here are the characteristics of homologous series. Number 1 says, each member differs from the successive one by CH2. I will say something about that. Number 2, they have the same general formula. Yes, for example, when we talk about alkane, it has this formula, CN H2N plus 2. Also, alkene has its own formula as CnH2n, whereas alkyne is CnH2n minus 2, so on and so forth. Number 3 says they have the same chemical properties. Yes, every member of each family exhibits the same chemical properties, and since they have the same chemical properties, that means they have the same method of preparation. Number 5 says they show gradation in the physical state. It means that from the first member to the fourth member is gaseous. Then from the 5th to the 12th is liquid. Whereas any member above 17 is wax-like solid. We have examples of homologous series. Number 1, alkane. If you want to get the first member of this family, the condition says that n should be greater than or equal to 1. Therefore, the first member will start at n equals to 1. Wherever you see n, you substitute 1. That will give us C1, H2 into 1 plus 2. And finally, we have CH4 as the first member of the family, and that is methane. In getting the second member, n should be equals to 2. You do your normal substitution. You have C2. 2 multiplied by 2 is 4, plus 2, that is C2H6. And the name is ethane. You are going to apply the same pattern in getting the remaining members of this family. Let's check if our definition is right, because it says that it differs from the successive member by CH2. Considering the first and the second one, where you have CH4 and C2H6, you can say 2 minus 1 is 1, which is C, and 6 minus 4 is 2, that is H2. So the difference is CH2. Okay, let's check the 4th and the 5th. You will see that C5 minus C4 will give you C, which is C1. And H12 minus H10 will give you H2. So we were right with the definition. Let's look at alkyl group. Alkyl group is a family of organic compound which is formed from alkane by the loss of one hydrogen atom. If there is a loss of one hydrogen atom from any members of this alkane, the corresponding alkyl will be formed. For example, if methane loses one hydrogen, it will form methyl. The condition starts from when N is greater than or equal to 1. So the first member of this family, we can say at N equals to 1. Let's substitute. Finally, you have C. 2 multiplied by 1 is 2, plus 1 is 3. That is CH3. And the name is methyl. You can see the only thing that changed here is the surname of the family. So assuming the surname of the alkyl is YL, whereas that of alkane is ANE, you see that the only changed thing here is the surname, whereas METH remain the same thing. That is to tell you that in the hydrocarbon, whenever you have one carbon, the prefix of the name must start with METH. Let's look at the remaining members of the alkyl group. And don't forget, you are going to continue applying the same method in getting the remaining members of this family. That is, the second one will be at N equals to 2. When you substitute, you have your answer. So you see, you have C2H5, that is ethyl, and we have C3H7 as propyl, C4H9 as butyl. When you have 2 carbon, the name will start with the prefix ETH. And when you have 3, the name will start with the prefix prop. The fourth one, the name will start with the prefix BUT. And that is how it is to the remaining members of the families. The next example is alkene. Alkene has its formula as CnH2n, but the condition here differs from the conditions we'll be seeing. It says that N should be greater than or equals to 2. So the first member of this family will start at N equals to 2. Let's go ahead and substitute. Wherever you have N, you substitute with 2. And that will be C2H4. The first member of this family is C2H4. And since it has 2 carbon, from what I told you earlier, 2 carbons start with the prefix ETH. And the ending is going to come from the family, which is ENE. So the name will be ethene. The same method is what you are going to apply in getting the remaining members of the family. And the name also will be corresponding with the number of carbon. The next example of homologous series we are going to discuss is alkyne. Alkyne has this general formula CnH2n-2, and the condition states that the N should be greater than or equal to 2. The first one will be at N equals to 2. So it will give you C2, then you have H, 2 into N, which is 2, minus 2. You have C2, 2 multiplied by 2 is 4, minus 2 is 2, that is H2. And it's the first member of this family. So guess the name. Since it has 2 carbon, that means the prefix of the name will be ETH, and the ending will be accompanied by YNE, showing that it's coming from the family of alkyne. This same method you are going to apply in getting the remaining members of the family. That is, when you talk about the second member, it will be at N equals to 3. The third member will be at N equal to 4. So on and so forth. Then the name will be corresponding with the number of carbon which it has, plus the surname of the family, which is YNE. The next example is alkanol, and it has its own general formula as CnH2n H2N plus 1 OH. The condition here is that it should be at N greater than or equal to 1. Some other person can decide to write the general formula of alkanol as ROH, where this R could be any member of the alkyl group. You still remember the members of the alkyl groups we listed? These were the members of the alkyl group listed. To form this alkanol family or the alkanol series, you can choose any members of this alkyl group followed by the functional group, which is OH, and the member will be formed. Or you can also decide to work with this formula CnH2n plus 1 OH. Whichever way, just know that you are doing the same thing. Because if you can recall, when we talked about the general formula for alkyl group, this was actually the formula. But now OH is added to it, meaning that this R actually represented the whole formula of alkyl. So let's look at the first member of the family. That is at N equals to 1. You are going to substitute. You have C1 H2 into 1 plus 1 OH. It will be CH3. That is 2 multiplied by 1 is 2 plus 1 is 3 OH. So it's the same thing as invoking this first member of the alkyl group and attaching the functional group to form the first member of the alkanol. The name is methanol because it has only one carbon. This is the same method you are going to apply in getting the remaining members of this particular family. Even to the 10th member, still maintain the same method. If you look at this, you actually understand that when we said that homologous series have the same formula, we are not lying. You still check if the member differs from the successive one by CH2. So you have 1 carbon here, you have 2 carbon here. 2 minus 1 is 1. You have 5 here and you have 3. 5 minus 3 is 2. So the difference is still the same CH2. The next example is alkanoic. That is the carboxylic group. You either call it alkanoic or the carboxylic group. And it has its own general formula as CnH2n plus 1 COOH. The condition when we talk about alkanoic is that the N should be greater than or equal to 0. Let me explain. The functional group is already bearing carbon. Let's take it at N equal to 0. You have C0 H2 into 0 plus 1 COOH. Since you have 0 here, that means this C is gone. And here you have 2 multiplied by 0, which is 0, plus 1. You have 1 hydrogen. And the next thing is COOH. The first member of the family still have 1 carbon, and the name is methanoic. When we talk about the second member, it's going to be at N equal to 1. The third member will be at N equals to 2. You apply the same pattern to get the remaining members of this series. Here we stopped at number 4. You can decide to get your own to number 10 or to any number you like. Keep applying the same method in the naming and in the calculation. So with this, we've come to the interesting part of this tutorial, and that is alkanoate or the ester. So the alkanoate or ester have its own formula as RCOO R prime, where the R could be the same or different alkyl group. We know what alkyl group is. This R and the other one can be any member of the alkyl group, be it the first one, the second one, the third one, name it. So, and they could be the same, or maybe the first R could be the first member of the alkyl group, and the second R will be the 5th member of the alkyl group, whichever way you want it. The forward reaction is called esterification, whereas the backward reaction is hydrolysis. This is the nature of the reaction. The double arrow shows that the reaction can proceed in any direction. either these two reacting to form ester and water, or ester and water reacting to form alkanoic and alkanol. Let's look at the first reaction. Let's consider reacting the second member of the alkanoic with the first member of alkanol. So that is CH3 COOH, which is the second member of the alkanoic, reacting with the first member of alkanol, CH3 OH, to give us CH3 COO CH3 plus H2O. In the reaction between alkanoic and alkanol to form ester and water, you first write the alkyl group of the alkanoic. This is the alkyl group of the alkanoic, which was written here. Then followed by the functional group of the alkanoate, which is COO, and this is COO. And lastly, the alkyl group from the alkanol, and this is it. In naming the alkanoate, you name the alkyl group of the alkanol before I talk about the alkanoic. So in naming this, we start naming from this end. Start naming from here. When we discussed about alkyl group, we'll call this methyl. Right? And coming over to this side, you have one carbon here and you have another carbon, which means there are two carbon here. From the prefix we've been using so far, whenever we have two carbon, it's referring to ETH prefix. To accommodate the surname of this family, which is OATE, this is going to be alkanoate. That is methyl alkanoate will be the name of this alkanoate. Another example we are going to look at is when the third member of the alkanoic, which is C2H5COOH, reacts with the third member of the alkanol, C3H7OH. Because initially we looked at when the first one from the alkanol reacts with the second one of the alkanoic. So now let's look at when the two are having the same number, like the third member reacting with the third member. That will give us C2H5COO C3H7. Don't forget the hint I gave you, that in the reaction between the alkanoic and the alkanol, you first write the alkyl group from the alkanoic, which is C2H5, followed by the functional group of the alkanoate, which is COO, and this is COO, and finally the alkyl group from the alkanol, and that is C3H7. Lastly, you have water. So in naming, you name from the alkyl group of the alkanol, which is from the end, and that is C3H7. C3H7, from the knowledge of alkyl group, is propyl. You have two carbon here plus this other carbon to give you 3 carbon, and 3 carbon starts with the prefix prop. Therefore the final name of this alkanoate is a propyl propanoate. There are other examples of homologous series that we may not be looking at to shorten this video. They include the alkanal, or you call it the aldehydes, the alkanone or the ketone, the alkoxide or eponite, or you call it ether, the amine and the amide. All of them, they have their formula. The alkanal is RCHO, where this R could be any member of the alkyl group. So if you invoke any member of the alkyl group and attach it here, whatever it gives you will be the corresponding member of the alkanal. And in the naming, you still apply the same pattern like you did in the previous examples of homologous series. When it has one carbon, the name shall be from the METH prefix, while the ending will be ANAL to accommodate the surname of this family. The same thing happens here. In the naming alkanone, you apply the same method as you applied in naming alkanoate. If you look at it, you know they have almost the same functional group. The difference is that when you talk about alkanone, you have only CO, whereas alkanoate is COO. But two of them have R before and after the functional group. So you apply the same method in the naming. In the alkoxide, it has a slight difference in the naming, but it's not a much deal. You have amine and the amide. All these things, if you want us to take time and make a video about them, just drop it in the comment section and consider it done. Let's get into the major deal which is iupac nomenclature. This has been the problem with so many students out there. Anybody who has taken time to watch this video to this point should consider him or herself lucky, because I am going to break it down in the language that even the layman will be marveled. The rules are listed here. The rule number 1 says, identify and number the longest continuous carbon chain. This will serve as a parent name for the hydrocarbon. The second, number in such a way as to give shortest distance to the substituent atom. The third, when two or more the same alkyl substituents are located on the parent hydrocarbon, use the prefix di. That's when you have 2, tri when you have 3, tetra when it's 4, so on and so forth, to represent the number of occurrence. Number 4, when different substituents are located on the parent chain, arrange them in the alphabetical order with digits to show their location in the chain. Number 5, always use hyphen to separate digits from alphabet and comma to separate digit from digit. So let's start with this simple hydrocarbon with just one substituent atom. Let's start by obeying the rule number 1. It says, identify and number the longest continuous carbon chain, which will serve as the parent name for the hydrocarbon. In numbering this now, let's count 1, 2, 3, 4. If you count this way, you have 4 carbon. Now let's check if it's really the longest or there's another one that's longer than it. If you count this way, you have 1, 2, 3, 4. This is still the same 4. What if you count this way? 1, 2, 3. Therefore, it's either you count this way or you count this way. So let's count this way. Don't forget, it says it will serve as the parent name for the hydrocarbon. The parent name now is 4 carbon. And when you have 4 carbon, you're talking about this particular prefix, but that's not all. Because when you talk about all these family, alkane, alkene, alkyne, they all have but as prefix for one of their members. Then you consider another thing. Is it having single, double, or triple bond? You have single bond or true. So it's coming from the family of alkane. So the longest continuous carbon there is butane. Okay. The second rule says number in such a way to give a shortest distance to the substituent. So if we number from here, we have 1, 2, 3, and 4. But if we number from this end, we have 1, 2, 3, and 4. The rule says number from the side that give the shortest distance to the substituent atom. Considering these two numbering now, which one give us the shortest distance to this particular CH3 attached to the longest continuous carbon chain? Of course, it should be from the right side, because on the right side we have it on the second position, but from the left side we have it on the third position. So the shortest distance is from the right. And on that second position, what substituent atom do you have? What you have is CH3. And CH3, from what we discussed in the alkyl group, is methyl. And the methyl is located in the second position in the longest carbon chain. So that is 2. It will give you 2 methyl. The 2 showing the position where it's located in the longest continuous carbon chain. And the methyl tells you what is located in the second position. Don't forget, the last rule says always use hyphen to separate digits from alphabet. Finally, you combine the name and it will give you 2-methylbutane. This is an isomer of pentane, but let's not go there because that's going to be our second video in organic chemistry. If you really want to keep enjoying this class, make sure you subscribe to this YouTube channel. The next example is displayed in the molecular formula. We are going to represent this in its structural form. Starting from here, we have CH3. That is, we have C, there is H here, there's another H, and there's another H. So even if we don't attach the H, all these strokes here indicates that there are H there. Then you go to the next carbon, and in the next carbon, you have one H, and the other one is CH3. The CH3, you can start to write it this way, or you can start to write just CH3 here. In the next carbon, you have 2H, one here, one here. You go to the next carbon, which is this. you have one H and you have another one as CH3. So you can decide to write it like this. They are all the same thing. You go to the next one, which is having 2H also. And lastly, you have another one which is having 3H. You count to be sure that you are correct. You have 1, 2, 3, 4, 5, 6 carbon, and here you have 1, 2, 3, 4, 5, 6. So you are right. You're not going to count all these ones in brackets because they are the ones attached to the continuous carbon chain, just as we did here. In the naming, you still start with the number 1 rule, which says count the longest continuous carbon chain and use it as a parent name for the hydrocarbon. So we'll count 1, 2, 3, 4, 5, and 6. If you count this way, 1, 2, 3, 4, 5, it will be shorter. So the longest one is this one that we counted. Counting from this end also, you have 1, 2, 3, 4, 5, and 6. The essence of counting from two ends is for you to identify the side that gives you the shortest distance to your substituent. The longest continuous carbon chain is 6 in number. Therefore, it's coming from the prefix hex. If you look through this, you will see that there is no double or triple bond. And when there is no double or triple bond, it means the hydrocarbon or the compound is saturated. And the only hydrocarbon that is saturated is the alkane family. So it will be hexane, which is the 6th member of the alkane family. Now, the second rule, number in such a way to give shortest distance to the substituent atom. If we number from left towards right, on the second position, we have an attachment. Then if you number from the right to left, on the third position, we have the attachment. Therefore, numbering from left to right give us the shortest distance to the substituent. That means you are going to have second position, which is 2. And what do you have in the second position? You have CH3. And CH3 is methyl. Also, you continue counting. 3, 4. On the fourth position, you have another methyl. There is no other substituent attached. Then the rule number 2 says when 2 or more the same alkyl substituent are located in the parent hydrocarbon, use the prefix di, tri, tetra, etc. to represent the number of occurrence. We have more than one substituent, and what we have here is 2 substituents. Therefore, we're going to use di, and this will give us 2,4-dimethyl-hexane. 2 telling you that methyl is in the second position in the longest continuous carbon chain, and 4 telling you that there's also another methyl on the fourth position. Let's look at another example in naming organic compound. We have C, double bond, another C, single bond, C, triple bond. There is no hydrogen attached here and here because this side has double bond, showing that it is unsaturated. And you know quite alright, when we talked about the family of alkene, they were having 2 hydrogen, lesser than the number of hydrogen atom in the alkane. That is why 1 hydrogen is not here and 1 is not here. At this side, 1 hydrogen is not here, 1 is not here, 1 is not here also, and 1 is not here, because the family of alkyne also has 2 hydrogen lesser than alkene family. In naming this, we'll count the longest continuous carbon. So let's count 1, 2, 3, 4, and that will come from the prefix but. Now they said count from the side that gives the shortest distance to the substituent or branch. So if you count from left to right, let's still number this way. So counting from here, on the first position you have double bond, and counting from here on the first position also you have triple bond. Then the question is, where do you count from? Since counting from the both end, you have something at the first position. Now count from the side where you have the triple bond, because triple bond shows that that side is unsaturated with triple bond, which means it will be more reactive than the side with double bond. That will give us the first position. We'll have triple bond, which is coming from alkyne, and you're not going to write alkyne in full. You just write the surname of the family. On the third position, you have another double bond. And remember, when counting, you be consistent in your counting. You can't count from this end and next time you count from the other end. And the name of the double bond indicates the family of alkene there. So you're not going to write the alkene in full. You only write the surname, which is ene. Now you're going to obey another iupac rule, which says when you have more than one substituent in the organic compound, that you should arrange them in the alphabetical order. E alphabetically appears before Y. So the final name is going to give you both 3 in 1 I. Another example is represented this way. If you look at this, you actually know that this is COO, and it's a functional group of alkanoate, where everything here is this alkyl group and everything at the other end is this alkyl group. Let's rewrite the formula so that it will be easy to name. Then you have C2H5. You have one carbon here, the other carbon making it C2. You have 3 hydrogen and 2 hydrogen making it H5, followed by the functional group, and finally C2, because you have 2 carbon, and H5, the 2 plus 3 hydrogens. In naming, we apply the same rule that we've learned earlier by naming this end first, and this end, the alkyl group you have here is ethyl, then followed by the alkyl group from the alkanoic, that is 3 carbon, and 3 carbon is a propanoate. So the final name is ethyl propanoate. With these few examples, we've come to the end of naming of organic compound. If there is anyone you think you need our attention, please drop it in the comment section and you'll be attended to as soon as possible. And don't forget, make sure you subscribe to this YouTube channel and also go through this practice question